Dog Gadgets. Live.
Hey, oh, there we go. Hey, it's Josh from Brown Dog Gadgets again. As always, here with my favorite producer, Pete.
Hello.
It's Pete. We're going to be having some fun by building a Lego maze that is controlled with an Arduino, meaning you can make an automated Lego maze. And that's pretty funky. And it's pretty easy to do. It only takes a little bit of nylon conductive tape, an Arduino, and a servo. You can have a nice automated Lego system. Now, granted, this thing also can be used, same process for all sorts of other automated Lego-based projects, or don't even need to use Lego. We're just using tape and Arduino. But you can make this into all sorts of crazy things and do fun projects with it. And to start things out, we're going to show you the project itself.
All
so
right.
Here's a video of it in action. Here. Oh, there we go. So it's a pretty standard Lego maze. As you can see, we're moving our ball around. And what we're using here is an Arduino that we put together for a crazy circuit system, and a couple strips of tape to activate a servo. And now there's a timer built in, and that timer will close the gate after a certain amount of time. So basically, the basic idea of this project is you're racing the maze. You're trying to get your little tiny ball bearing here to get from point A to point B before that gate closes. And again, using the same approach, you can do all sorts of fun automated things. Let me get centered in my little circle here. There we go.
Centered.
Yay, I'm centered. So let's take a peek at the parts that we have here. And first and foremost, in case I forget, if you want to find the written directions and the code for this project, you can go to browndoggadgets.com. It's documented in our online documentation system. We have pictures, step-by-step guide, all the parts you need, and the Arduino code to make this project. And as a fun caveat, let me just say, you don't have to buy any of our parts here. You can do this exact same project without anything from browndoggadgets.com, your source of fun STEM activities and materials. Not to sound too markety there. But you can do this with a regular Arduino Nano, Arduino Uno, just any Arduino-compatible board possible, and a standard servo. So you want to do this out of cardboard or Lincoln Logs, whatever materials you have around. I think cardboard's the next thing past Lego that everybody has.
Oh, pasta.
Pasta. I want to see a pasta-based maze happening.
Okay, we'll work on that.
It's definitely more fun out of pasta, a ravioli maze. So
Yeah.
let's look at the parts we have available to us today. First and foremost, the brains of this project is one of our Crazy Circuits robotics boards. This is an Arduino Uno at its center. That is Lego compatible. The parts just pop onto Lego, and this one's already popped on and popped well into place. And they're handy, they're fun. We have a whole bunch of different ones of these, but we chose the robotics board here because it has these built-in pin headers in the back for easy servo connections. Because we want to make sure our servo is connected nice and solidly. If you're using a regular Arduino Uno, you could just say plug it directly in, I think, to the Uno itself. Yeah, you should be fine. Or any other Arduino board. We're using some of our nylon conductive maker tape. This is what we're going to use to activate the push button aspect of this. To activate things, we have a metal ball bearing. This is actually one that's used for a Lego part, but it is just a half-inch steel ball bearing. Anything conductive would work. We have this wonderful little servo here. This is one of the geek servos that we have on our website. This is a standard, it's actually 280 or 270, my bad. 270 servo, right. There we go. But it's Lego compatible, so we can actually pop it into Lego to do stuff with, which is really, really handy. And a few different Lego Technic pieces. We've got a couple spot pieces here, a couple little connectors, and a couple little axles and other things to make our connection complete. Now, if you were going to be doing this project as a nice big maze, you want to make sure you get yourself a nice big tub of Lego, which I'm going to keep to the side over here, a crud ton of Lego to make the maze itself. And that's probably like a Lego maze. You can always reconfigure it any way you want. So let's get making this little project today. So we are not going to be making the full maze because we'll be here forever making a fun maze.
It's a long project, right? Yes.
We're going to make the electronics and the simple mechanics of this to work. Oh, one thing as well, our code actually has a countdown timer with a piezo speaker on there. We're not going to do that today, but it just beeps faster and faster based on how much time you have left on your countdown. And in the code, you can change the delay between when it lifts and drops, so you can make it shorter or longer depending on how mean you want to be in your Lego maze. So first and foremost, we've pre-programmed our board. So, Pete, would you show everybody the directions? We went to our website and grabbed the code.
Let's see. We've got our web page.
There we go.
Right?
So we went to our documentation system here, and we scroll down to the part where we have our Arduino code. We also have a nice big video of how to do this. We have the diagram. When we downloaded the Arduino code and uploaded that to our Arduino. Again, it's already written for you. You can change it around if you want, but it's there. That is literally like half the work involved in this project is uploading the code, like any good Arduino project.
You got it.
Great. So yeah, that's it. There's a link there to our GitHub repo where we actually have that. But there's our full directions set there. Next, I'm going to make a platform for my my board to hang out on. I could say hang this off of one piece if I wanted to, but since we don't have Lego holes in the middle of our PCB here, we have to build a platform either with a plate, or I'm just going to use these big bricks here so that it's easy for everyone to see what's going on. And next, we're going to apply our tape. This is how you make your switch. We're just going to really cut 2 pieces of tape, any length you want for your switch. There you go. And we're going to apply that to our project. Now, our code has us using a ground pin, and then our setup, it's pin 9 we're using, which are side by side here for easy access. Mm-hmm. You could use any pins you want as long as one is ground and one is a digital pin. We're just going to lay that down on here.
Actually, we got a comment here from a viewer. A guy named Ben Nelson says, amazing. It's a bit of a play on words there. Amazing. Come on.
Ben Nelson has now been banned.
Okay, Ben, you've been
banned.
That's
it. No.
Ben is banned.
No more puns from you.
All right.
It's his punishment.
Ooh, wow.
Oh. It's amazing. Anyone?
Is it only Tuesday?
I'm surprised I'm here on Tuesday. Thanks, Gobi. That's kind of nice outside today here in Wisconsin. By the way, Wisconsin, it was snowing on Sunday.
Yes.
It's like 60 degrees.
So, Josh, let me ask you about this tape I see you using again.
Oh, Pete, what kind of questions do you have about this amazing nylon conductor
what's
tape?
the magical properties of this tape that makes it worth using in this project?
Well, this was actually blessed by the Fairy King himself.
Wow. Ben Nelson.
I have seen him dance around in small wings. No, this is our wonderful proprietary maker tape. It's a nylon conductive tape. This is the 1/8" tape. It works really well with Lego. We also have 1/4", which is the same thing, just thicker. It's nice because it's super sturdy. It'll go on the Lego, also come off again when you're done. It's durable and flexible and way stronger than copper foil. Do not do this with copper foil unless you're running like a wire from an Arduino to like some copper foil on something, because copper foil never comes up again off Lego.
Yeah,
I know.
We have pieces that still have some on there.
Ages and ages ago,
3
years ago, we actually tried getting some copper foil with Lego holes punched in it as a test, and we put it on a few pieces, and we never took them off because it took so much time to peel this horrible stuff off. And so there's a few randomly in my big old tub of Lego there.
But your tape there, as I understand, conductive both sides and all the way through.
It is. So if you make it too short. Now, the nice part is, if you want to, say, make your switch over here and your Arduino over here, just run tape, right angle fold, overlap, whatever, over there, as long as you have 2 that are close together so that your ball bearing can roll across a spot where they're side by side, and it will make a connection. This will be your button press.
One other thing I like, too, is you can easily just lay tape on top of another piece.
Yep.
And it just widens then whatever you've got. You don't have to, like, connect to the bottom or the top.
Nope.
You know,
that's the nice part of being conductive on top and bottom. So the big thing that annoyed me when I was teaching that your copper foil tape was not reliably conductive on top and bottom.
Right.
So, yeah, good time. So there we go. That's it. I then put my board on top. Everything's in place, and the pressure fit with the conductive tape underneath our little Lego holes here makes a solid electrical connection. Or if you really want to get lazy, you can just run it up over the top, but putting it over the board on top of the tape means it's nice and solid, nothing will come undone, and you've got a really strong connection.
It's nice. I built a robot with that, and I put it in my bin and carried it here, and it was still connected. Nothing fell off. The board really stays on nice and tight.
Yeah, that tape is great. It just changes everything. So now we're going to take our servo, and we are going to plug it into the pin header for pin 3 on the back end. Ta-da! And that's it. Our electronics is literally done until we plug in our power source. We programmed it, we've wired everything up, and now we are we are good to go. So, ta-da. Now let's talk about the mechanics of things, because that's always where everyone gets stuck with Lego. We're using a few Lego Technic pieces here, and we've got this nice little... I totally feel bad because I did not look up the names of these parts. There's a lot of ways of doing this, by the way. But we're using this guy here, this piece, which is 5 long by 3 tall with a little swoop on it. There's an official Lego number for this. And we're using a axle to peg here so that it'll stay in place on the end. But still this piece here, Technic beam is the term, can still swivel. And we're using another Technic beam. I'm using the red ones here. I've got the 2 peg here so that they'll both move independently. This is so we have a little bit of action going on.
Yeah.
So that things will sweep, move, and bend a little bit more. Again, you can do this all sorts of different ways. This is just the way we found well with our setup when we were building it in that video and the photos we have.
Yeah.
And so then this will just go onto here.
This is the best part, because if you've ever gotten just a little hobby servo, there's a tiny little screw. You can kind of screw some things in. You can kind of hot glue to maybe put a horn on, but it's figuring out that connection, which right there is like it just pops on and it's great.
That's why we like the Geek Servo. Somebody did what we wanted to do for ages, and we have a couple different versions of this: a continuous rotation, a just dumb motor, and the 270 servo.
Yeah.
But yeah, it pops on because it has a Lego axle on the end.
Nice.
And it just works really, really, really well. It's like 95% of what I'd ever wanted in this project, or for a servo for Lego.
Yeah.
And there's really not much else out there that is easy to work with Arduino. I know we tried doing this 3D printing our own like Lego adapters for the 9G hobby servos. And I never had good luck with that because Lego is such tight tolerances.
Yeah.
And no matter how much I dialed in my 3D printer, getting everything to work well together just never worked out well.
Right.
For that. So we even used to laser cut some different servo adapters, which they worked. They did. Pete here to help designed them. They worked okay, but they weren't great. So this is just a really easy way of hooking up Lego to a servo. And then from then on out, you just got to figure out how to get everything lined up. Now, the only annoying thing about these guys is they have no way to lay flat against something. You could use a L-shaped Lego piece and use this. We actually found sometimes with using this servo in a mechanical moving structure, we're grabbing like a 2x2 brick or a 2x2 round piece here with an axle hole in there and pressing this in here. So there's a little bit of give on our servo so it can move up and down a little bit. It has a little bit of stress relief, so to speak, and do that with both of them. And that gives us a little bit of flexibility. Whoops.
We should do a whole series on the different way we've connected those servos and motors.
Yep.
Because I think we've come up with a couple different kind of ways to do it.
Yeah, and I've
document them all.
I've started to put up on our documentation system Lego build techniques, or just how to connect crazy circuits with Lego. Such like how if you want to make an entirely, I'm just gonna do this. Make an entirely. I can't see.
I think I did 2 tall last time. Is you doing 2 of them tall?
No, I'm just doing 1 tall.
Oh, it's 1. Okay.
I started doing how to use different Lego pieces to interact directly with crazy circuits components, such as a crazy circuit button. So you could press a Lego button, like a Lego piece up top, and activate the button below. Switches as well. If you want to make a fully Lego system, I think you're right. I think 2 high was the better approach on this, Pete.
That's because I did it a week ago.
Yeah, I can. Here, I want to make life easy. We have tons of Lego here.
We do.
If only we had a box full of Lego within arm reach.
Speaking of that, I mean, if you've got a giant box of Lego or bin or tub of Lego at home, I mean, I feel like the Crazy Circuits is kind of the next step to really go crazy and do some cool stuff.
There we go. So now this should work a bit easier, I think.
Oh, yeah.
I don't know. It's been a while. But anyway, that's a technique. So we can then do that. So we're going to turn on our Arduino here, and you can see this function not properly because I totally forget exactly how we did that. But that's the basic. We have photos on our.
Meanwhile, look, Josh, we've got our friend
John
Chavone, I believe.
Oh, John, we missed you. We thought you didn't like us after last time.
Yeah, hey, and if you're watching this, you leave some comments, questions, whatever we'll answer those.
We have no shame.
Well, I do. A little bit.
It's true. I have seen your Twitter account.
Oh, boy.
Nothing but cats.
Oh, boy.
It's true.
Yeah.
Cats everywhere. The man loves his cats.
Well,
That's the nice part about Lego, though. You can just keep doing tons of crazy stuff with this. So anyway,
Yeah.
I've got this, get things back into frame. I've got this little external power bank since we're pre-programmed, but plug into any USB power source. We'll turn this guy on. There we go.
yeah.
There's a little bit of getting everything worked out appropriately, but it's in an up position. And then our ball bearing here would roll across. It moves backwards. Thing moves out of the way.
Yeah.
And it's going to do a countdown, which we then move things around. And it went back to the position. What we did originally with this was because trying to keep things all lined up, we actually made a tunnel or wow, I'm using the wrong words today. We made a wonderful system where we could keep our Lego pieces in place. There we go. We made a channel for a Lego piece here to go in and out of.
What about some sort of track, maybe?
Track, there we go. That's what we did for this guy. So this could move in and out very easily.
Yeah.
And again, using different sizes of your whatever those Lego
beams.
Beams. There we go.
Those are beams, I think.
I was getting like, they're not bricks, they're beams. Lego beams.
There's a lot of nomenclature involved in your Lego
So many Lego
world.
pieces. Anyway, that's it. It's a simple cause and effect. If you have the piezo speaker lined up, it'll beep for you. But that's it, and then it goes back to place. Hit this button, it goes out of the way, and look, it's out of the way now. And if we had a track in place, it'd probably help things get back to where it should be again. And that's where a track would be really handy.
Didn't we have a fully assembled maze somewhere?
We did, but some really nice fellow took it home with him
Oh,
a while back.
That makes
and
sense, yeah.
that tends to happen with things around here. People take them
Yep.
home. I know, amazing. Let's see if this will work now with my track. There it goes, out.
ooh, nice.
And then if I didn't have this here, because I made those way too long,
Right.
probably make life easier. Yeah, and you can, again, playing around with the Lego mechanics is the easy part.
Josh, I would say like anything, what we're doing is giving you sort of the base and idea to get
Yes.
started,
And-
and the mechanics of how to do it, and then you go from there.
Pretty much. That's what I like to do is here's how we did things.
Uh-huh.
Here's a base thing to start with, and then
Yeah.
do your thing. But I love using Legos. They're very kid and adult friendly. You can just do so much with them. And doing some Arduino-based lighting, motion, sound effects is so simple to do. And it doesn't take much effort because there's so much great Arduino stuff out there. I mean, we put this together in no time whatsoever. And the hard part with anything Arduino-based is typically the code for people, and that's where we give you the code, you modify a couple of numbers, you want to change the timing on it, but it's not tough to do. I think there you go. And we can just keep futzing around with this guy until we get things lined up properly. Oh, it almost did it. If I can just get you like here and stuff. I'm so close to making this work again. It's so long ago we did that.
One thing I love about the Lego is it's test and retest. I mean, that's what we do a lot when we're teaching kids. Is like, hey, try this, see what happens. If it didn't work, try another thing.
There it goes.
Yeah,
and
you got it.
And the big thing is like with the other one that we did, like this little end bit here, because we had all this channeled out. This is where your ball would go through.
We've got a comment here from our friend Ben.
Red and the green.
Yeah,
I don't know what the colors are because I'm colorblind. Nelson.
Sorry about that.
Unless you make fun of my disability.
Yeah. So he's saying a piece over the top would, keep
mean
the
like
beam from pop.
Like I did.
Yeah, like that exactly.
There's a time delay between.
There's a time delay.
Like when
He's
people
going to see this
things
and say, "Wow, they did what I said before I told him."
Classic Nelson. Classic Nelson. But yeah, it's so easy to do.
That was pretty quick and easy.
Yeah. So I love these Geek servos. Are really, really, really handy. They're pretty inexpensive too. I think we have them for $4 or $5 on our website for a Lego-based servo. Continuous rotation is good. You want to build like an Arduino tank, or Pete. We showed a project that Pete had made a couple weeks ago where it's just 2 of those servos on a very simple Lego platform with the Arduino above. It's just rotating on a table.
Robot.
I think we're going to add a distance sensor to that guy in the future.
Yeah.
But yeah, that's it. Lego Maze. Like you just need a couple of Technic pieces here, little time to play with stuff, and back and forth. It doesn't take much. There you go.
Yeah. Should we show them the video again?
Sure, why not the video? Version of what we did before.
Yeah. That's a full build, so it takes a little longer, but
Oh yeah, I guess guess we hooked it up a different way last time.
Yeah.
I guess I had the wrong connection on that. Oh well.
But again, you just keep trying things.
Try that out.
Have fun.
Mechanics are, once you know how the electronics are there. Yeah, there you go. Oh, see, I used a smaller piece last time. I used too big of a piece on this one. That's why I'm all screwed up.
It's all right. Okay.
Classic. Yay. Yeah, this is too big of a piece. Anyway,
too big?
thanks for watching. If you like our stuff, follow us on social media. You can find it in all these fun
Look at all that.
overlays. We'll be posting here a lot of projects. Tomorrow we're doing a Crazy Circuits ambulance. We can also do the Papercraft ambulance circuit with blinking LEDs using some parts. We're doing that with Make Magazine through Maker Camp, which will be done on their Maker Camp thing. But we're posting that project up tomorrow for that as well, and show that off on Friday. And Thursday we have a fun arts and crafts person coming in. Yes, it's a surprise. Hopefully she can come. She's supposed to be coming. We're just trying to get all the timing worked out. But she does some high end arts and crafts, like really nice greeting cards. Our cards are just like thick, but those are nice cards using our fun conductive tape. Actually, our Maker
Once
tape.
again, our cards, everything we do is inspiration. It's to give you ideas and get you going.
I mean, like we're doing like fun art, and she's doing like high
end art. Yeah,
like
that's great.
Really nice, like Hallmark greeting cards.
Wow,
like the kind of thing you'd pay some good quality money for at a craft store.
I mean, I made a cat with laser eyes.
You did. He did make a cat with laser. I mean, I make
high
squid.
End right there.
I make
You
light
did
up
make
squid.
Yeah.
So that's kind of like the levels of the
that's
stuff we're
pretty
doing
good,
as I
yeah.
play with
Not
this
bad.
ball bearing,
Right.
like David Bowie in Labyrinth, only much smaller. So thanks for coming before we get too far in the weeds and horrible movie references.
Right.
But we'll be back again tomorrow with Make Camp, and we'll be around 3-4 days a week showing off some cool stuff. And with any luck, we'll have our microbit component in on Friday.
Nice.
It's currently being soldered up, and hopefully it'll be sent, and we'll have one to show off, like the finished version.
Awesome.
Which is a finished prototype, which will hopefully be 99% what we want to do for our final version. So thanks for watching. We've been on here too long.
We'll roll those credits.
Let's roll those credits.
All right.
Take care. Bye. See you later.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. Check out our live streams at Facebook, YouTube, and Twitch. We'll see you next time.